In the 2nd century AD, a man named Claudius Ptolemy sat in the great library of Alexandria and tried to solve a cosmic puzzle. The sun and moon moved predictably across the sky. The stars were a fixed backdrop. But a few bright lights, the planets, were troublesome, or they wandered. The Greek word for them, planetes, literally meant wanderers. Sometimes they would even slow down, stop, and move backward against the stars for a few weeks, a phenomenon called retrograde motion. This broke the simple idea that everything just circled the Earth. Ptolemy's solution was genius, and it was complicated. He kept the Earth at the center of everything. That was the common sense view. To explain the strange planetary motions, he proposed a system of circles on top of circles. A planet didn't just orbit the Earth on a big circle called a deferent. It also moved on a smaller circle, an epicycle, which was itself moving along the deferent. By carefully choosing the sizes and speeds of these circles, Ptolemy could perfectly explain the observed paths of the planets, including their backward loops. His model was incredibly successful. It was laid out in his book, The Almagest, which became the definitive astronomical text for over 1,400 years. If you wanted to know where Jupiter would be on a specific night, Ptolemy's system gave you the right answer. Sailors navigated by it. Astrologers cast horoscopes with it. It was a powerful, predictive, and useful piece of science. There was just one problem. The entire foundation was wrong. The Earth is not the center of the universe. The planets do not move on epicycles. The model worked, but it was a description of a reality that didn't exist. And it was a clever illusion that produced the right results for the wrong reasons. Our intuitive feeling of no is a lot like Ptolemy's model of the cosmos. It feels completely real. It's the most obvious thing in our experience. We organize our entire lives around the past, the future, and this razor-thin moment of the present. So it works for getting to work on time, for having a conversation, for living a life. It's a useful, practical concept, but when we look closer, when we really examine it with the tools of physics, neuroscience, and philosophy, the whole idea of a single universal now starts to look like an illusion. It seems to be a clever model our brains create, one that works on a human scale but doesn't reflect the fundamental nature of the universe. The solid ground of the present moment begins to feel like a fiction, a convenient story we tell ourselves about a universe that is far stranger than we can easily grasp. Number 18. Your digital now is a lie. The latency of a video signal from the cameras used at the Super Bowl to your television is around 7 seconds. When you see a live touchdown, millions of people have already been cheering in the stadium for several seconds. High-frequency trading firms have spent over $1 billion laying a new, straighter fiber optic cable between Chicago and New York just to shave 3 milliseconds off the communication time. A single search on Google requires data to travel an average of 1,500 miles, a journey that, despite happening near the speed of light, still takes between 200 and 500 milliseconds to complete. We live in a world that feels instantaneous. We send a message and it appears on a screen halfway around the world. We join a video call and see the faces of colleagues in different countries. We talk about being connected in real time. But this idea of real time is a fiction built by technology. Every single piece of digital information you send or receive is delayed. It is a ghost from the past. The delay might be tiny, measured in thousandths of a second, but it is always there, and it fundamentally breaks any notion of a shared now. Think about a simple video conference. You are in London and your colleague is in Tokyo. When you speak, your voice is converted into digital data. This data is broken into tiny packets. These packets travel through cables, routers, and switches, often under the ocean, before being reassembled on your colleague's computer and turned back into sound. This entire process takes time. Let's say it takes 150 milliseconds. Your colleague in Tokyo is always living 150 milliseconds in your past. And you are living 150 milliseconds in their past. Your two nows are not aligned. You are having a conversation across a time gap. For most conversations, this is unnoticeable. Our brains are good at smoothing over these tiny gaps, but as the delay increases, the illusion shatters. Anyone who has been on a satellite phone call with its noticeable half-second lag knows the feeling. You talk over each other. The rhythm of conversation breaks down. You become acutely aware that you are not sharing the same moment. You are sending messages into the past and waiting for a reply from the future. This isn't just about conversation. It's about the very fabric of our global systems. The world of finance is a prime example. In high-frequency trading, algorithms buy and sell stocks in microseconds. A microsecond is a millionth of a second. The physical limit on how fast this can happen is the speed of light. If a trading firm in New York gets market data from London a few microseconds before a competitor, it can make millions of dollars. This is why companies build microwave towers to send signals in a straight line through the air, which is slightly faster than sending them through fiber optic cables that have to bend around geography. They are literally in a race against the laws of physics to make their now a tiny bit closer to the actual event than their rivals. The entire industry is built on exploiting the fact that there is no universal no. There is only information arriving at different times in different places. The problem gets even more extreme when we deal with space. When NASA sends commands to the Curiosity rover on Mars, the radio signals, traveling at the speed of light, take anywhere from 4 to 24 minutes to get there, depending on the alignment of the planets. The engineers on Earth are working with a now on Mars that is long past. They might send a command to turn left. By the time the signal arrives, the rover could have already fallen into a crater. They have to plan every action based on predictions, sending up a whole day's worth of instructions at a time. They are communicating with a ghost. The rover's no and our no are completely disconnected. Our reliance on GPS provides another example. Your phone's GPS receiver works by picking up signals from multiple satellites orbiting the Earth. Each signal contains a timestamp indicating the precise time it was sent. Your phone calculates your position by measuring the tiny differences in the arrival times of these signals. But for this to work, the clocks on the satellites have to be incredibly accurate and perfectly synchronized. And here's the catch: due to the principles of Einstein's relativity, which we will explore later, the clocks on the satellites actually run at a different speed than clocks on Earth. They run faster. If engineers didn't constantly correct for this relativistic effect, GPS systems would become inaccurate by several miles every single day. The system only works because we acknowledge and mathematically correct for the fact that time itself, and therefore the moment of no is not the same everywhere. Our digital world is an intricate network of delays. Every email, every stock trade, every live stream is a message from the past. The immediacy we feel is an illusion, a testament to how fast information can travel, but it is not true simultaneity. We are all living in slightly different moments, separated by the time it takes for light and electricity to carry information between us. The idea of a single global no, where everyone experiences the same event at the same instant, is a physical impossibility in our connected world. Number 17, the universe has no center. For most of human history, we believed we were at the center of everything. The Earth was the special, privileged location around which the entire cosmos revolved. The sun, moon, and stars were all there for us. This idea, the geocentric model, felt right. It matched our everyday experience. This view collapsed when Nicolaus Copernicus showed in the 16th century that the Earth was just another planet orbiting the sun. It was a humbling demotion. But the sun then became the new center. Our solar system was special. Then astronomers like William Herschel in the 18th century began to map the stars and realized the sun was just one star among billions in a vast flattened disk we call the Milky Way galaxy. For a while, we thought our sun was at the center of the galaxy, but in the 1920s, Harlow Shapley studied clusters of stars and showed that our solar system is actually located out in one of the spiral arms about 2/3 of the way from the galactic center. Another demotion, the final blow to any idea of a central location, came from Edwin Hubble, also in the 1920s. He observed that distant galaxies were all moving away from us, and the farther away a galaxy was, the faster it was moving away. This led to the understanding that the universe itself is expanding. A common misconception is to picture this as an explosion from a central point in space. But that's wrong. The expansion is happening everywhere at once. The fabric of space-time itself is stretching. Think of the surface of a balloon with dots drawn on it. As you inflate the balloon, every dot moves away from every other dot. No single dot is the center of the expansion. An ant living on any one of those dots would look around and see all the other dots rushing away from it, creating the illusion that it was the center. This is our situation in the cosmos. No matter which galaxy you are in, you will see all other distant galaxies moving away from you. There is no special place in the universe. There is no center. How does this relate to the concept of no? The idea of a universal now implicitly assumes a privileged frame of reference, a master clock for the universe. It suggests there is some central point from which we can measure a single cosmic time. But if there is no center to space, why should there be a center to time? If no location is special, why should any moment be special? The cosmological principle, a fundamental assumption in modern cosmology, states that on large scales, the universe is homogeneous and isotropic. Homogeneous means it's roughly the same everywhere. Isotropic means it looks the same in every direction. This principle implies that the laws of physics are the same everywhere. There's no cosmic up or down, and no cosmic here. This lack of a special undermines the idea of a universal now. As we'll see when we discuss relativity, the now you experience depends on your motion and location in a gravitational field. If there were a cosmic center, we could perhaps define a master now based on the state of that central point. All other no's could be calibrated against it. But without a center, which reference frame gets to be the real one, an observer in the Andromeda galaxy moving relative to us will have a different definition of no. An observer in a galaxy near the edge of the observable universe, receding from us at a significant fraction of the speed of light, will have a wildly different definition. None of these definitions is more correct than any other. The expansion of the universe itself complicates our idea of time, because the universe is expanding, light from distant objects gets stretched on its journey to us. This is called cosmological redshift. It means the past looked different. The early universe was hotter and denser. The future will look different as it becomes colder, emptier, and more spread out. Time in the universe is tied to this process of expansion. It's not just a static clock ticking away against a fixed background. It is part of the dynamic, evolving nature of the cosmos. The absence of a physical center forces us to abandon the idea of a temporal center. Our now is just one local now in a vast, centerless universe. It holds no privileged position. Billions of other no's exist for billions of other observers in billions of other galaxies, each one valid from its own perspective, but none of them the definitive universal no. The universe doesn't have a capital city, and it doesn't have a master clock. Number 16, philosophy cannot pin down the present. Around 400 AD, the philosopher Augustine of Hippo was wrestling with the nature of time in his book Confession. He famously wrote, "What then is time? If no one asks me, I know. If I wish to explain it to one that asketh, I know not." His confusion centered on the present moment, the no. He reasoned that the past no longer exists and the future does not yet exist. All that is real is the present. But what is this present? If the present has any duration, any length, then it must have parts. It must have a beginning and an end. But if it has a beginning and an end, then part of it is already in the past, and part of it is still in the future. So only a fraction of that present moment is actually present. You can keep dividing this moment down smaller and smaller into microseconds, nanoseconds, and beyond. You are forced into a conclusion for the no to be purely present with no contamination from the past or future. It must have zero duration. It must be an infinitesimal dimensionless point. But if the now has zero duration, how can anything happen in it? How can there be motion or change? A moving arrow at any single instant of no duration is stationary. To perceive motion, you need a span of time, a before and an after. If the present moment is a point with no length, it cannot contain the process of becoming. It is frozen, and a reality made up of a succession of these frozen zero duration moments seems impossible. It's like trying to build a line out of points that have no length. This is the classic philosophical dilemma of the present. Either it has duration and is therefore not truly present, or it has no duration and therefore seems to not exist at all. This has led to two major philosophical schools of thought about time presentism and eternalism. Presentism is the common sense view. It holds that only the objects and events in the present are real. The Battle of Hastings is not real anymore. It's in the past. Your 100th birthday is not real yet. It's in the future. The only reality is the fleeting moment of now. This aligns with our intuition, but it struggles with the problem of a zero-duration present and has great difficulty explaining how the present moment moves from one point in time to the next. What pushes it forward, and what is it moving through if the future doesn't exist? And eternalism, on the other hand, proposes a radical alternative. It suggests that the past, present, and future are all equally real. The universe is a four-dimensional block of space-time. Time is just another dimension, like length, width, and height. The Battle of Hastings is a real event located at a specific set of coordinates in space-time England, 1066. Your 100th birthday is also a real event at another set of coordinates. The now is just the slice of this block that you happen to be experiencing at this particular moment. Your consciousness moves through this block, illuminating one moment at a time, but the block itself is static and complete. This view is also known as the block universe theory, and it aligns surprisingly well with Einstein's theory of relativity. In the eternalist view, the feeling of now is a subjective illusion. There is nothing special about the present moment, any more than there is anything special about the location her. Hair is just where you are. Now is just when you are. The dinosaurs are not gone. They are just located at a different point in the time dimension. The future is not unwritten. It is just a region of the space-time block you haven't reached yet. There is also a third view called the growing block theory. It's a compromise. It suggests that the past and present are real, but the future is not. The universe is a block of space-time that is actively growing as the present moment adds a new slice of reality to it. The past is fixed and real, but the future is a realm of open possibilities that have not yet solidified into existence. The fact that philosophers for thousands of years have been unable to agree on the fundamental nature of the present moment is telling. They have debated it, dissected it, and applied rigorous logic to it, only to end up with several competing and irreconcilable theories. If the concept of now were simple and fundamental, we would expect to have a clear philosophical account of it. Instead, we have a series of paradoxes and deep disagreements. The problem is that our language and our intuition are built for a world of simple, flowing time. But when we try to formalize this intuition, it collapses under logical scrutiny. The now is easy to experience, but seemingly impossible to define. It may be that the very question, what is now, is based on a flawed premise, like asking what is the edge of the universe or what is north of the North Pole. The concept itself might be the problem. Number 15, memory constructs your present. The year is 1890. The psychologist and philosopher William James publishes his landmark work, The Principles of Psychology. In it, he coins the term specious present. Specious means something that seems true but is actually false. James argued that the now we experience is not an infinitely thin razor's edge between past and future. Instead, it is a short duration, a saddle back of time with a certain breadth of its own. It has a vaguely vanishing backward and a vaguely coming forward part. He estimated this duration to be a few seconds long, perhaps up to 12 seconds. Think about listening to a sentence. If your now was an infinitesimal point, you could only ever hear one single sound vibration at a time. You could never hear a whole word, let alone a sentence. To understand the sentence, the cat sat on the mat. You need to hold the beginning of the sentence, the cat, in your mind as you hear the end, on the mat. Your conscious experience is not of a single point in time, but of a small window of time. This window is the specious present. It is constructed by your short-term or working memory. The now you feel is not a direct perception of the present moment. It is a fusion of immediate sensory input with very recent memory. Your brain takes the fire hose of information coming from your senses and stitches it together into a coherent, flowing experience. The feeling of continuity of one moment smoothly leading to the next is a product of this memory-based construction. Without this working memory, your experience of the world would be a series of disconnected snapshots, a confusing and meaningless barrage of stimuli. Neuroscience backs this up. The brain regions involved in working memory, like the prefrontal cortex, are constantly active, holding and manipulating information over short periods. This is the neural machinery behind the specious present. When you watch a movie, you are not seeing continuous motion. You are seeing a series of still frames projected at 24 frames per second. Your brain, using its short-term memory, blends these frames together to create the illusion of movement. Your perception of no works in a very similar way. It's not a direct feed of reality, it's a heavily processed and edited film created by your brain. This reliance on memory makes our sense of no highly subjective and malleable. Consider a piece of music. An experienced musician hears a chord not just as a set of notes played at that instant, but in the context of the entire musical phrase. Their specious present is colored by the memory of the chords that came before and the anticipation of the chords that will follow. A non-musician might just hear the chord in isolation. Their experience of that now is different. This also explains why our perception of time can stretch and shrink. When you are engaged in a fascinating activity, your brain is processing a lot of new information and forming rich memories. Later, when you look back, this period seems to have been long and full. When you are bored and waiting for something to happen, your brain is not forming many new memories. The period feels like it's dragging on forever in the moment, but when you look back, it seems to have passed in a flash with nothing to show for it. The now you experience is being built by the activity of your memory systems. The implications are profound. The objective physical moment is a theoretical concept. The subjective experience no is a psychological reality created by your brain. And that creation is not instantaneous. It relies on the past. Your consciousness of this moment is fundamentally a reflection on what has just happened. You are always experiencing a memory of the present. This means the now is not a window onto the world as it is, but a story about the world as it was a fraction of a second ago, constantly updated and presented to your consciousness as a seamless whole. The present you inhabit is not found, but made, and it is made from the raw material of the past. Number 14, quantum mechanics dissolves the moment. In 1927, Werner Heisenberg formulated his famous uncertainty principle. It states that you cannot simultaneously know with perfect accuracy both the position and the momentum of a particle. The more precisely you measure its position, the less precisely you can know its momentum, and vice versa. This isn't a limitation of our measurement tools, it's a fundamental property of the universe. At the quantum level, particles don't have definite properties until they are measured. Before a measurement, an electron exists in a superposition of states, a cloud of probabilities. This has strange consequences for the idea of no. We tend to think of the present moment as a definite, specific state of affairs. The cat is on the mat, the car is at a specific location, moving at a specific speed. But quantum mechanics says that at the most fundamental level, the universe is not in a definite state now. It is in a state of fuzzy potentiality. The now is not a sharp snapshot, but a blurry cloud of overlapping possibility. The act of observation or measurement seems to be what forces the universe to choose one of these possibilities, a process called the collapse of the wave function. So is the definite no we experience created by our own consciousness? This is a controversial and mind-bending idea that some physicists like John von Neumann and Eugene Wigner have seriously considered. It suggests that the universe only becomes concrete when a conscious mind observes it. Before that, it's just a sea of probabilities. This would mean that no isn't an objective feature of the universe, but something that is co-created by the observer. Another quantum mystery that challenges our notion of now is entanglement. If you have two entangled particles, say two electrons, their properties are linked in a spooky way. For example, their spins might be correlated. If you measure the spin of one electron and find it is spin up, you will instantly know that the spin of the other electron, no matter how far away it is spin down. This happens instantaneously, seemingly faster than the speed of light. Albert Einstein famously called this spooky action at a distance. This instantaneous correlation seems to violate the rule from relativity that nothing can travel faster than light. How does the second particle know what happened to the first one? It suggests some kind of connection that operates outside of normal space-time and defies our conventional understanding of cause and effect happening in a sequence of no's. If two events can be linked instantly across vast distances, it breaks the idea that the now is a purely local phenomenon. It points to a deeper, non-local layer of reality where our concepts of space and time don't apply in the usual way. The problem of now gets even deeper when physicists try to combine quantum mechanics with general relativity to create a theory of quantum gravity. One of the most famous attempts to do this resulted in the Wheeler-DeWitt equation, formulated in the 1960s. This equation describes the wave function of the entire universe, but it has a very strange feature. The variable for time, is completely absent. The equation is timeless. This doesn't mean that time doesn't exist, but it suggests that at the most fundamental level of reality, the one described by quantum gravity, there is no flow of time. There is no special no. Instead, the universe is a static quantum state. The passage of time that we experience would have to be an emergent property, something that appears at larger scales, like the way temperature emerges from the average motion of molecules, even though a single molecule doesn't have a temperature. In this view, the universe is a vast collection of nows, all existing simultaneously in a quantum superposition. Our consciousness, for reasons we don't yet understand, experiences these nows in a particular sequence, creating the illusion of a flowing river of time. But the river itself is just a collection of still water droplets. Quantum mechanics replaces the clockwork, deterministic universe of Isaac Newton with one that is probabilistic, fuzzy, and interconnected in strange ways. It tells us that the state of the universe now is not a single, well-defined reality. It is a haze of potential realities. The very act of trying to pin down the now changes it. The concept of a solid, objective present moment dissolves into a sea of quantum uncertainty. Number 13. Your brain creates a fictional now. In the mid-19th century, the German scientist Hermann von Helmholtz conducted a simple experiment. He would briefly flash a sheet of letters to subjects and ask them to recall as many as they could. They could typically only name 4 or 5. But they had the distinct feeling that they had seen more letters, but the image faded before they could name them. This hints at a fundamental process in our brain We perceive a rich, detailed world, but our conscious mind only gets access to a heavily edited summary. Your brain is a master storyteller, and its greatest fiction is the smooth, continuous, and high-resolution experience of now. The raw data coming from your senses is actually chaotic, gappy, and incomplete. Your brain works tirelessly behind the scenes to patch the holes, smooth the bumps, and present a coherent narrative to your conscious self. One of the most striking examples of this is saccadic masking. Your eyes are not like video cameras smoothly panning across a scene. They move in very fast, jerky movements called saccades. You make about 3 saccades every second. During the moment of the saccade itself, your vision is essentially shut off to prevent you from experiencing a dizzying blur. This means that for a significant portion of your waking life, you are functionally blind. Yet, you never experience these blackouts. Your brain simply edits them out of your perception. It takes the snapshot of vision before the saccade and the snapshot after and stitches them together, creating the illusion of a continuous visual world. The now you see is a fabrication, a composite image with the messy parts left on the cutting room floor. There's also the phenomenon of the phi effect. If you flash 2 lights in sequence at 2 different spots, with the right timing, you don't perceive 2 separate flashes. You perceive a single light moving from the first position to the second. This is the basic principle behind neon signs that create the illusion of motion. But think about what this means for your brain's perception of no. In order to perceive the motion, your brain has to know where the second light is going to appear. It seems to process the event of the second flash and then retroactively create the experience of motion between the two. The now you experience is not what's happening at that instant, but a conclusion your brain has drawn after all the data is in. The philosopher Daniel Dennett calls this the multiple drafts model of consciousness, where the brain is constantly revising its story of what's happening right now. This editing process also applies to sound. If you hear a sentence where a cough or a burst of static obscures one of the words, your brain will often fill in the missing word based on the context of the sentence. This is called phonemic restoration. People in experiments report actually hearing the missing word. Their brain hasn't just guessed what the word was, it has created the auditory experience of the word and inserted it into their know. All these examples point to the same conclusion. The conscious experience of the present is not a live broadcast from the senses. It is a delayed, edited, and reconstructed model of the world. Your brain is not a passive receiver of information. It is an active interpreter, a prediction machine that is constantly trying to make sense of the noisy and incomplete data it receives. It uses its past experience to generate a hypothesis about what is happening right now, and this hypothesis is what you experience as reality. This means your now is not a direct reflection of the external world. It is a neurological construction, a user interface for reality. Just as the icons on your computer desktop are a simplified representation of the complex electronics inside, your conscious now is a simplified representation of the unfathomably complex physics of the outside world. This interface is incredibly useful for survival. It allows us to react to predators, find food, and navigate our environment. But it is not the territory itself, it is just a map, and a map that is drawn a fraction of a second after the territory has already been explored. Number 12. You are always living in the past. In the 1980s, the neuroscientist Benjamin Libet conducted a series of experiments that sent shockwaves through the fields of neuroscience and philosophy. He asked subjects to watch a clock and to flick their wrist whenever they felt the urge. They also had to note the exact time on the clock when they first became aware of their intention to move. Libet was also measuring their brain activity with an EEG. he discovered something astonishing. The brain activity associated with preparing for the movement, a signal called the readiness potential, began about half a second before the subject reported feeling the conscious urge to move. The implications are staggering. Your brain appears to have already decided to act before you are consciously aware of the decision. Your conscious experience of making a choice in the present moment seems to be one of the last things to happen in the chain of events. It's like a press secretary who is informed of a decision only after it has been made by others, but still announces it to the world as if they made it. This is just one manifestation of a more general principle. Our entire conscious awareness lags behind physical reality. It takes time for light to travel from an object to your eye. It takes time for the photoreceptors in your retina to convert that light into a neural signal. It takes time for that signal to travel along the optic nerve to the visual cortex at the back of your brain. And it takes time for your brain to process all this information and construct a conscious perception. Scientists like David Eagleman estimate this total lag to be around 80 milliseconds. So the now you are experiencing is not the real now. It is the world as it was about 80 milliseconds ago. You are always living in the very recent past. This might not seem like a long time, but in the world of physics and high-speed events, it is an eternity. A bullet can travel over 20 feet in that time. Your brain has developed clever tricks to compensate for this delay. One of them is called postdiction, which is the opposite of prediction. The brain essentially revises its story of what happened based on later information. A classic example is the flash lag effect. If you see an object moving across a screen and a light flashes at the exact moment the object is in the center, you will perceive the flash as lagging behind the moving object. Your brain, in its effort to predict the trajectory of the moving object, essentially moves its perceived position forward in time to compensate for the processing delay. It shows you where it thinks the object will be in your conscious now, not where it actually was when the light hit your eyes. This delay also explains why it feels like a touch on your nose and a touch on your toe happen at the same time, even though the nerve signal from your toe has to travel a much longer distance to your brain. If your brain processed these signals as soon as they arrived, the toe touch would feel noticeably later. Instead, the brain seems to wait for all the relevant sensory data to come in before it compiles its official story of that moment. It collects all the information and then presents it to you as a single, unified now, effectively post-dating the nose signal to match the arrival time of the toe signal. This has profound consequences for our understanding of things like sports. When a professional baseball batter faces a 95-mile-per-hour fastball, the ball travels from the pitcher's hand to the plate in about 400 milliseconds. It takes about 100 milliseconds for the visual information to even reach the brain, another 150 milliseconds for the brain to process it and generate a motor command, and 25 milliseconds for that command to travel to the muscles. The total time needed is dangerously close to the total flight time of the ball. There is simply no time for a conscious decision to be made in the batter's swing is an act of a highly trained subconscious system that is operating on prediction, not on a real-time perception of the present. The batter is swinging at where the ball will be based on a model built from a perception of the past. The feeling that you inhabit a present moment, making decisions, and experiencing the world as it happens is a powerful illusion. Your conscious mind is like a historian, not a live reporter. It is constantly receiving dispatches from the front lines of your senses, which are already out of date, and weaving them into a coherent narrative of what just happened. You are always one step behind the universe. Number 11, time's arrow flies in only one direction, but physics doesn't know why. In 2004, scientists at the Babar experiment at Stanford and the Bell experiment in Japan confirmed a subtle but crucial asymmetry in the behavior of subatomic particles called B-mesons. They found that these particles decay differently depending on whether time is running forward or backward. This was a confirmation of a phenomenon known as CP violation, and it is one of the very few places in fundamental physics where a distinction between the past and future is found. This is shocking because almost all the fundamental laws of physics are time-symmetric. The equations of general relativity, quantum mechanics, and electromagnetism work just as well if you run the variable gamed, for time forward or backward. A video of two billiard balls colliding would look perfectly normal if you played it in reverse. A video of a planet orbiting a star would also look perfectly normal in reverse. At the microscopic level, the universe doesn't seem to have a preferred direction for time. There is no arrow of time built into the basic laws. Yet, in our macroscopic world, the arrow of time is undeniable. The eggs break, but they don't UN break. Ice cubes melt in a glass of water, but a puddle of water never spontaneously forms an ice cube. We remember the past, but we don't remember the future. We are born, we grow old, and we die. This one-way flow of time is perhaps the most fundamental feature of our experience of no, the sense that it is a moving frontier between a fixed past and an open future. So, where does this arrow of time come from? The most widely accepted explanation comes from the second law of thermodynamics. This law states that in an isolated system, the total amount of entropy or disorder will always tend to increase over time. A broken egg is a more disordered state than a whole egg. A melted ice cube is a more disordered state than a frozen one. The universe as a whole is moving from a state of low entropy to a state of high entropy. The arrow of time is therefore just the direction of increasing entropy. The reason we experience time as moving forward is that we are living in a universe that is still in the process of winding down. The ultimate source of this arrow is the fact that the universe began in an incredibly low entropy state at the Big Bang, a very hot, dense, and highly ordered condition. We don't know why it started this way. It's a mystery known as the past hypothesis. But given this special starting condition, the rest of the universe's history is simply the inevitable slide towards maximum disorder. This has profound implications for the concept of no. It suggests that the distinction between past and future is not a fundamental property of time itself, but a statistical and emergent one. The now is not a moving spotlight, but simply a moment in a universe that has a particular entropy gradient. The past is the direction of lower entropy, and the future is the direction of higher entropy. The physicist Sean Carroll argues that this could even allow for the theoretical possibility of other universes where time runs backward. If the multiverse as a whole is in a state of timeless high entropy equilibrium, our Big Bang could have been a random fluctuation into a low entropy state. Or it's possible that another fluctuation could have spawned another universe from the same event where entropy increases in the opposite temporal direction. An observer in that universe would experience their past as our future, and vice versa. Furthermore, our psychological arrow of time, the feeling that we are moving forward in time, is also tied to entropy. The process of forming a memory involves creating ordered connections in the brain, a process that requires energy and increases the overall entropy of the universe through heat dissipation. Or we can only form memories of the past because the past was a lower entropy state than the present. You can't have a memory of the future because that would require the universe's entropy to decrease, violating the second law. So the feeling of now as the leading edge of a forward-moving process is a consequence of the thermodynamic state of our universe. It's a feature of our macroscopic complex reality, but not a feature of the underlying timeless laws of physics. If the universe had been born in a state of maximum entropy, a state of thermal equilibrium, nothing would ever happen. There would be no change, no processes, no arrow of time, and no meaningful concept of no. The now only exists because the universe is on a one-way journey from order to chaos. Number 10, your experience of time's speed is a personal illusion. In 1962, the French caver Michel Siffre spent 2 months living in a cave deep underground with no clocks, no calendar, and no sunlight. He conducted experiments on himself to see how the human body would adapt to the absence of external time cues. When he finally emerged on September 17th, he thought it was only August 20th. His subjective sense of time had slowed down so dramatically that he had lost 28 days. His personal now had become disconnected from the now of the outside world. Our perception of the passage of time is not a faithful measurement of some objective, ticking clock. It is a highly subjective experience, a construction of the brain that can be warped and distorted by a huge range of factors. The no you experience is not the same as the no someone else experiences, even if you are sitting in the same room. One of the biggest factors is attention. When your brain is paying close attention to the passage of time, such as when you are waiting for, a pot to boil, time seems to slow down. Your brain dedicates more resources to monitoring the temporal dimension of your experience, and this increased processing makes the interval feel longer. Conversely, when you are completely absorbed in an activity, in the flow, you are not paying attention to time, and it seems to fly by. The phrase, "a watched pot never boils," is a literal description of a psychological phenomenon. Emotion also has a powerful effect. Fear, in particular, can make time seem to slow to a crawl. Studies by neuroscientist David Eagleman have shown that when people are in a life-threatening situation, like a fall from a height, they later report that the event seemed to happen in slow motion. This isn't because their brain actually sped up its processing. Instead, it's likely due to the amygdala, the brain's fear center, going into overdrive and recording memories with much higher density and detail. When you replay this dense memory later, it feels like it must have taken a longer time to unfold. The now of a terrifying moment is a now that is being recorded in high definition. Age is another critical variable. Almost universally, people report that time seems to speed up as they get older. A summer seemed like an eternity to a 10-year-old, but a year passes in a flash for a 50-year-old. There are several theories for why this happens. One is proportionality. For a 5-year-old, a year is 20% of their entire life. For a 50-year-old, it's only 2%. Another theory relates to novelty. A child's life is filled with new experiences, which require more mental processing and create stronger memories. An adult's life is often more routine. The brain doesn't need to record as much detail about the 500th time you've driven to work. Fewer novel memories means the period seems shorter in retrospect. Even body temperature can alter our time perception. And studies have shown that raising a person's body temperature can make them perceive time as passing more slowly, while lowering it can make time seem to speed up. This suggests that our internal biological clock, the rhythm of our metabolism, is a key input for our brain's construction of time. All of this demonstrates that the now is not a fixed duration moment that we all experience equally. It is a flexible, personal, and biologically grounded perception. The objective time measured by an atomic clock, which ticks with relentless regularity, is a human invention, a tool we use to coordinate our activities. It does not reflect our lived experience. The now of a child is different from the now of an adult. The now of a person in fear is different from the now of a person who is bored. The very texture and pace of the present moment is a subjective creation of your individual brain. There is no universal speed of now. Number 9, gravitational time dilation means your head ages faster than your feet. In 1971, physicists Joseph Hafele and Richard Keating flew 4 cesium beam atomic clocks on commercial airplanes around the world, once eastward and once westward. When they returned, they compared the time on these clocks to a reference clock that had remained on the ground at the U.S. Naval Observatory. They found that the clocks no longer agreed. The flying clocks were out of sync with the ground clock by a few hundred nanoseconds. This experiment was a direct confirmation of Einstein's theory of relativity. Part of the discrepancy was due to the speed of the planes, an effect called kinematic time dilation. But another part was due to the plane's altitude. This is gravitational time dilation, one of the most bizarre and non-intuitive ideas in all of physics. Einstein's theory of general relativity, published in 1915, describes gravity not as a force, but as a curvature of spacetime caused by mass and energy. The more massive an object, the more it warps the spacetime around it. A consequence of this warping is that time itself runs at different rates, depending on where you are in a gravitational field. The stronger the gravity, the slower time passes. This means that a clock at sea level will tick slightly slower than a clock on top of a mountain. A clock on the surface of the sun will tick much slower than a clock on Earth, and a clock near a black hole where gravity is extreme will tick incredibly slowly compared to a clock far away. If you could hover near the edge of a black hole for a few hours and then return to Earth, you would find that thousands or even millions of years had passed for everyone else. This isn't a mechanical effect on the clock. It's not that gravity is making the gears run slower. It affects everything: biological processes, chemical reactions, the decay of radioactive particles. All processes that unfold in time are slowed down. Time itself is passing more slowly. This effect is not just theoretical or limited to extreme environments. It is happening to you right now. Because your head is slightly farther away from the center of the Earth than your feet, it is in a slightly weaker gravitational field. This means that time is passing a tiny bit faster for your head than it is for your feet. The difference is minuscule, on the order of a few parts in a quadrillion, but it is real and measurable with modern atomic clocks. Your head is aging faster than your feet. This completely shatters the idea of a single no for even a single person, let alone the entire universe. If different parts of your body are moving through time at different rates, what does no even mean? Or is it the now of your feet or the now of your head? There is no single answer. The Global Positioning System GPS is a daily, practical proof of gravitational time dilation. The GPS satellites orbit about 12,550 miles above the Earth. At that altitude, gravity is weaker, so their onboard atomic clocks run faster than clocks on the ground by about 45 microseconds per day. They are also moving at high speed, which causes their clocks to run slower by about 7 microseconds per day due to kinematic time dilation. The net effect is that the satellite clocks gain about 38 microseconds on ground clocks every single day. If this relativistic effect were not accounted for, GPS navigation would be off by about 6 miles per day. The system only works because the satellites are programmed to constantly correct for the fact that their now is different from our now. The concept of a universal now assumes that time flows at a constant rate for everyone, everywhere. General relativity shows us that this is fundamentally wrong. Time is relative. Its pace is determined by the local gravitational environment. Every planet, every star, every galaxy has its own local time. There is no master clock, no universal beat to which the cosmos marches. The now of an observer on Earth is different from the now of an observer on Mars, which is different from the now of an observer in another galaxy. Each is a valid local measurement of the passage of time, but none of them can claim to be the true universal now. Number 8, the speed of light is the ultimate killjoy. The star Proxima Centauri is the closest star to our solar system. It is about 4.24 light years away. A light year is the distance light travels in a year. This means that the light we see from Proxima Centauri when we look up at the sky tonight actually left the star 4.24 years ago. We are not seeing the star as it is. No. We are seeing it as it was in the past. If Proxima Centauri were to explode tomorrow, we wouldn't know about it for another 4.24 years. This is a simple but profound consequence of the fact that the speed of light, while incredibly fast, is not infinite. Light travels at approximately 186,282 miles per second, or 299,792 kilometers per second. in a vacuum. This is the ultimate speed limit of the universe. No information, no object, no causal influence can travel faster than light. This fact, which is a cornerstone of Einstein's theory of relativity, completely demolishes the idea of a universal instantaneous no. Everything you see is in the past. The light from your computer screen takes a nanosecond or so to reach your eyes. The light from the moon takes about 1.3 seconds. The light from the sun takes about 8 minutes and 20 seconds. If the sun were to vanish from the sky, we would continue to see it shining and feel its warmth for over 8 minutes. We live in a universe of delays. The farther away you look, the deeper you look into the past. When astronomers look at the Andromeda Galaxy, the nearest major galaxy to our own, they are seeing it as it was 2.5 million years ago. The light from that galaxy began its journey when our early human ancestors were just beginning to walk the plains of Africa. When we use powerful telescopes like the Hubble or the James Webb Space Telescope to look at the most distant galaxies, we are seeing them as they were over 13 billion years ago, just a few 100 million years after the Big Bang. We are looking at the universe in its infancy. Astronomy is a form of time travel. This speed limit on information means that the concept of now is strictly local. You can talk about what is happening now in the room you're in, because the light travel time is negligible. But you cannot, in any meaningful way, talk about what is happening now on Mars or now in the Andromeda Galaxy. There is no way to know. The information hasn't reached us yet. Any statement about the state of a distant object right now is a speculation, an extrapolation based on past data. It is not an observation of a present reality. Imagine you have a friend on a hypothetical planet orbiting Proxima Centauri. You try to synchronize your watches, you send a signal to them that says, "It is 12 p.m. now." Your signal, traveling at the speed of light, will take 4.24 years to reach them. When they receive it, their local time might be completely different. They can send a signal back saying, "Got it, it's 12 p.m. now for me too," but that signal will also take 4.24 years to get back to you. By the time you receive their confirmation, over 8 years will have passed on your clock. There is no way to establish a shared simultaneous no between the two of you. This isn't just a problem of measurement or technology, it is a fundamental feature of the structure of space-time. The universe is not a place where events happen on a universal stage at a universal time. It is a web of cause and effect where events can only influence other events that are within their future light cone. The present moment across the entire universe is an unobservable, and therefore physically meaningless, concept. What is happening now on a planet a billion light years away? The question itself is based on a false premise. The universe does not have a now. It has a here and now. Each point in space-time has its own local present, but these presents cannot be stitched together into a single, cohesive cosmic sheet of simultaneity. The speed of light acts as a cosmic curtain separating each local now from all others, and ensuring that we are always inevitably looking at a picture of the past. Number 7, kinematic time dilation means your now is not my now. In 1905, Albert Einstein, then a 26-year-old patent clerk in Bern, Switzerland, published his theory of special relativity. It was built on two simple but revolutionary postulates. First, that the laws of physics are the same for all observers in uniform motion, and second, that the speed of light in a vacuum is the same for all observers, regardless of their own motion. The consequences of these two ideas were earth-shattering, and one of the most famous is kinematic time dilation. Time dilation means that a moving clock runs slower than a stationary clock from the perspective of a stationary observer. The faster you move through space, the slower you move through time. This isn't a metaphor. It's a physical reality. If you were to travel on a spaceship at 99% the speed of light for every 1 year that passed for you on the ship, about 7 years would have passed on Earth. If you returned after what felt like 5 years to you, you would find that 35 years had gone by for everyone you left behind. This effect is negligible at the speeds we encounter in everyday life, but it becomes significant as you approach the speed of light. It has been experimentally verified countless times. Particle accelerators like the Large Hadron Collider at CERN have to account for it every day. Subatomic particles called muons are unstable and decay very quickly, in about 2.2 microseconds when they are at rest. But when they are accelerated to near the speed of light, their lifespan, as measured by scientists in the lab, increases by a factor of 30 or more. From our perspective, their internal clocks are running slow. From the muon's perspective, its clock is running normally, but the distance to the detector has shrunk. Time dilation completely destroys any notion of an absolute universal no. The now you experience is directly tied to your state of motion. If I am standing still and you are flying past me in a fast jet, my now and your now are ticking at different rates. And we are progressing into the future at different speeds. This leads to the famous twin paradox. Imagine two twins. One stays on Earth, while the other goes on a long journey in a super-fast spaceship. When the traveling twin returns, she will be younger than her sibling who stayed at home. This is not a paradox in the sense of a logical contradiction. It's a proven physical effect. The two twins have experienced different amounts of time because they have been in different frames of reference. There is no single objective amount of time that has passed. This effect is not just about clocks and aging. It is about the very simultaneity of events, a concept we'll explore next. If two people are moving relative to each other, they will not agree on which events are happening now. What one person sees as a simultaneous occurrence of two events, the other will see as one event happening before the other. Our intuition, built from a lifetime of experience at very low speeds, tells us that time is absolute. We assume that a second is a second for everyone, but this is just an approximation that works well in our slow-moving world. The universe does not operate on this principle. The faster you move, the more you stretch the duration of your present moment relative to others. Think about what this means. Now is not a universal constant. It is a personal, motion-dependent variable. Every object in the universe, from a subatomic particle to a galaxy, has its own proper time, its own rate of passage through the temporal dimension. These times are related to each other through the equations of relativity, but they are not the same. The concept of a universal now requires a universal clock, a single rhythm for the entire cosmos. Special relativity shows us that this is impossible. There are as many different rates of time as there are different states of motion. My no might be ticking slower or faster than the no of an alien in a spaceship flying past Earth, and both are equally valid from their own perspective. The universe has no preferred frame of reference and therefore no preferred now. Number 6. The block universe theory makes now a subjective illusion. In the late 19th and early 20th centuries, the mathematician Hermann Minkowski, one of Einstein's former teachers, was working to find the best mathematical framework for his students' theory of special relativity. In 1908, he gave a famous lecture where he declared, "Henceforth space by itself and time by itself are doomed to fade away into mere shadows, and only a kind of union of the two will preserve an independent reality." He had realized that space and time are not separate entities, but two aspects of a single, four-dimensional continuum he called spacetime. This is not just a mathematical convenience, it represents a profound shift in our understanding of reality. We are used to thinking of the world as a three-dimensional space where events happen over time. The now is the reality that currently occupies this space, and it moves, changing from one moment to the next. The space-time view suggests something completely different. It suggests that all of reality, past, present, and future, is laid out as a static, four-dimensional block. And time is just another dimension like length, width, and height. This concept is often called the block universe or eternalism. In this view, the past is not gone, and the future is not unwritten. Everything that has ever happened and everything that ever will happen already exists at its specific coordinates in the space-time block. The dinosaurs are not extinct in some absolute sense. Their existence is a permanent feature of the space-time block at an earlier temporal coordinate. Your death is not a future possibility. It is a real event that already exists at a later temporal coordinate. So why do we experience the passage of time? Why does it feel like now is a special moving moment? According to the block universe theory, this feeling is a subjective illusion created by our consciousness. Our consciousness illuminates one slice of this space-time block at a time, creating the sensation of a flowing present. The now is not a property of the universe, it is a property of our perception. It's like reading a book. All the words of the story, from beginning to end, exist simultaneously on the pages. But you experience the story sequentially, one word at a time, as your eyes scan across the page. The entire book exists, but your no is just the word you are currently reading. This view is strongly supported by the physics of relativity. As we have seen, relativity shows that there is no universal now. Different observers, moving relative to each other, will slice up the space-time block into space and time in different ways. They will disagree about which events are simultaneous. This is very hard to reconcile with the idea that only the present is real. If my now and your now are different slices of space-time, which one is the real one? The block universe solves this problem by saying that all slices are equally real. The entire block exists, and different observers are just perceiving it from different angles. The implications for free will are, of course, enormous. If the future already exists in the space-time block, then it seems that all of our choices are predetermined. The feeling that we are making decisions in the know that shape an open future would be an illusion. The script has already been written. Many physicists and philosophers are uncomfortable with this deterministic picture and the loss of a dynamic unfolding now. They have proposed alternative interpretations, but the block universe remains the most straightforward and elegant interpretation of what the mathematics of relativity seems to be telling us about the nature of time. In this view, the distinction we make between past, present, and future is not a fundamental feature of reality. It is a feature of human experience. The universe does not have a no. It just is. The entire timeline of the cosmos, from the Big Bang to its ultimate end, exists as a single, timeless, four-dimensional object. Our deeply held intuition that the now is a special, privileged moment is just that, an intuition, a product of our minds, not a reflection of the underlying structure of the universe. Number 5. The Andromeda paradox shows now depends on a stroll. In the 1960s, the philosopher and physicist Hilary Putnam proposed a thought experiment, later refined by Roger Penrose, that uses Einstein's theory of relativity to demonstrate the absurdity of a universal now. It's called the Andromeda paradox, and it shows that the now you experience can be radically different depending on something as trivial as which direction you are walking. Here's how it works. Imagine there are two people. Let's call them Alice and Bob. If Alice is on Earth, sitting perfectly still, Bob is also on Earth, but he is walking at a leisurely pace towards the Andromeda galaxy. The Andromeda galaxy is 2.5 million light-years away. It is home to billions of stars and planets, and let's imagine that on one of those planets, a fleet of alien spaceships is preparing to launch an invasion of Earth. According to special relativity, two observers moving relative to each other will have different planes of simultaneity. A plane of simultaneity is just all the events in the universe that are happening now for a particular observer. For Alice, who is sitting still, her plane of simultaneity is a slice through space-time that is flat relative to her. On this slice, let's say the aliens in Andromeda are still on their planet, making their final preparations. For Alice, the invasion has not yet begun, no. Now consider Bob. He is walking towards Andromeda. This seems like an insignificant motion, but according to relativity, even this tiny velocity is enough to tilt his plane of simultaneity. Because Andromeda is so incredibly far away, this tiny tilt has a huge effect out there. It's like tilting a very long lever. A small movement at your end creates a massive movement at the far end. And Bob's plane of simultaneity is tilted such that his now in the Andromeda Galaxy is actually 24 hours in the future compared to Alice's now. This means that for Bob, at the very moment he is walking on Earth, the alien invasion fleet has already launched and has been traveling towards Earth for a full day. So for Alice, the aliens are now on their planet. For Bob, who is just a few feet away, the aliens are now one day into their journey. Now imagine a third person, Carol, who is walking away from the Andromeda Galaxy. Her plane of simultaneity will be tilted in the opposite direction. Her now in the Andromeda Galaxy will be 24 hours in Alice's past. For Carol, the aliens have not even made the final decision to launch. So we have 3 people on Earth, all within a few feet of each other, who have 3 completely different versions of what is happening right now in the Andromeda Galaxy. For Alice, the aliens are preparing. For Bob, they are already on their way. For Carol, they are still undecided. Which now is the correct one? According to relativity, all of them are. There is no absolute correct answer. The state of a distant event, is not a fact about the universe. It is a fact about your state of motion. This is not a theoretical fantasy. It is a direct and unavoidable consequence of the well-tested theory of relativity. It shows that the idea of a universal now is not just unobservable, but logically incoherent. If we accept that there is a single objective now across the universe, then we have to decide if the aliens have launched or not. But the answer depends on whether you are walking towards them or away from them. An objective fact about reality cannot depend on which direction a person on Earth is taking a stroll. The Andromeda paradox is a powerful illustration of the relativity of simultaneity. It forces us to abandon our intuition that there is a single cosmic present moment that we all share. The no is not a universal plane cutting through time. It is a personal, perspective-dependent slice of space-time. And the angle of that slice, and therefore what is contained within your now, is determined by your motion. Number 4, the brain's binding problem means your now is a clever trick. When you look at a red ball bouncing, you have a single, unified experience. You see its shape, its color, and its motion all at once, all belonging to the same object in the same moment. But in your brain, this is not how it works. The information about the ball's color is processed in one part of your visual cortex. The information about its motion is processed in a completely different area, and the information about its shape is processed in yet another. Furthermore, these different attributes are processed at different speeds. The brain processes color faster than it processes motion. This creates a puzzle for neuroscience known as the binding problem. How does the brain take all these separate streams of information, which are processed in different locations and at different times, and bind them together into the coherent, unified conscious experience of a single red ball bouncing now? The brain seems to solve this problem with a clever timing trick. One leading theory, proposed by neuroscientist Andreas Engel and others, suggests that the brain uses synchronized neural oscillations, or brainwaves, to link the different processing areas. When neurons in the color area and the motion area fire their electrical signals in the same rhythm, at the same frequency, often around 40 hertz, in the gamma wave range, the brain treats these signals as belonging to the same object and binds them together into a single perception. It's a bit like a conductor using a single beat to get all the different sections of an orchestra to play together. But think about what this means for the concept of no. The unified no that you experience is not something that is given to you by the outside world. It is an active construction, a synthesis that your brain creates after the fact. It has to take the color information, which arrives first, and essentially hold it back until the slower motion information has been processed. Only then can it synchronize the signals and present the final bound perception to your consciousness. Your experience of no is therefore a temporal illusion. The simultaneity you perceive is not real simultaneity. It is a neurological invention. The brain is creating a best guess story of what is happening at the same time based on its own internal timing mechanisms. This explains some strange perceptual phenomena. For example, if you see a brief flash of light and hear a brief click at the exact same time, your brain has no problem binding them. But sound travels much slower than light, and your brain processes auditory information faster than visual information. To compensate, the brain has a certain temporal window of integration. It will treat sights and sounds that occur within a small time window up to about 100 milliseconds apart as having happened at the same time. This is why the sound and picture in a movie can be slightly out of sync without you noticing. Your brain is actively resynchronizing them for you. This binding process is fundamental to all of our conscious experience. It's how you know that the sound of a voice is coming from the person's mouth you are looking at, or that the feeling of a texture belongs to the object you are seeing. Your entire coherent reality is built on this neural binding. But this means that the now is not a sharp, clear moment. It is a slightly fuzzy, averaged-out window of time, a construction site where your brain is constantly working to stitch together different pieces of information that arrived at different times. The now is not a reflection of a pre-existing unity in the world. It is a fragile unity that your brain imposes upon the world. It's a useful fiction that allows us to interact with our environment effectively, but it's a fiction nonetheless. The smooth, unified present is the brain's greatest magic trick. Number 3, there is no universal clock. For most of human history, time was local. Each town set its own clocks by the sun. When it was noon in one town, it might be 12:10 in a town a few miles to the east. This wasn't a problem when travel was slow, but in the 19th century, the rise of the railroads changed everything. Trains traveling at high speeds needed a synchronized schedule to avoid collisions and run efficiently. In 1883, the major railroad companies in the United States agreed to divide the country into 4 time zones. This was the beginning of standardized time, the idea that large regions should share the same now. In 1884, the International Meridian Conference was held in Washington, D.C. to establish a global system of time. This led to the creation of Coordinated Universal Time (UTC), the standard by which the world regulates clocks and time. UTC is maintained by the International Bureau of Weights and Measures in France, which averages the signals from about 400 highly precise atomic clocks in over 50 laboratories around the world. It is the closest thing humanity has to a single master clock. But this clock is a human invention. It is a social and technological construct, not a fundamental feature of the universe. As we have seen from relativity, the universe itself has no master clock. There is no central pacemaker ticking away the cosmic seconds. Einstein's theories of relativity, special and general, showed that time is not absolute. The rate at which time passes depends on your motion special relativity and your location in a gravitational field general relativity. An atomic clock on a fast-moving satellite runs slower than one on Earth. An atomic clock on the ground runs slower than one on a mountaintop. These are not just theoretical predictions, they are measured effects that we have to account for in technologies like GPS. This means that the very idea of a perfectly synchronized network of clocks is a physical impossibility. Even the 400 atomic clocks that define UTC are not perfectly in sync. They are constantly being adjusted and correlated with tiny relativistic corrections being applied to maintain a consensus time. But each clock is fundamentally experiencing its own local flow of time. If we cannot even establish a perfect now across the surface of our own planet, the idea of establishing one across the cosmos is hopeless. Imagine trying to synchronize a clock on Earth with a clock in another galaxy. That galaxy is moving away from us at high speed. meaning its time is dilated relative to ours. It is also in a different gravitational environment. The light signals we would use to communicate and synchronize would take billions of years to travel between us. The project is not just technologically difficult, it is physically and conceptually meaningless. The universe is a collection of countless local clocks, all ticking at their own rates. Your body's biological clock, the clock in your phone, the clocks on GPS satellites, the spin of a distant pulsar, the decay of a radioactive atom, each is a valid timekeeper in its own frame of reference. But there is no way to privilege one of them as the true clock. There is no universal time to which all others can be compared. The now that we coordinate through our time zones and UTC is an incredibly useful tool for global communication, commerce, and science. It allows our complex society to function. But we should not mistake this useful convention for a deep truth about the universe. The universe is chronologically democratic. It does not have a king or a president. It has a multitude of local constituents, each with its own valid perspective on time. The now is not a universal declaration, it is a local opinion. Number 2, the relativity of simultaneity means now is a matter of opinion. This is perhaps the single most profound and difficult idea to come out of Einstein's theory of special relativity. It is the rock upon which our entire intuitive notion of a universal now is shipwrecked. The relativity of simultaneity states that two events that are simultaneous for one observer may not be simultaneous for another observer who is in motion relative to the first. Simultaneity is not absolute. Einstein explained this with a famous thought experiment. Imagine a long train moving at a very high constant speed. A person, let's call her the train observer, is standing in the exact middle of a train car. Another person, the platform observer, is standing on the ground as the train speeds past. At the exact moment the train observer passes the platform observer, two lightning bolts strike the train, one at the very front and one at the very back. The platform observer, being stationary, sees the light from both strikes travel an equal distance to reach her eyes. The light from the front and back strikes arrives at her eyes at the same time. So, for the platform observer, the two lightning strikes were simultaneous events. They happened at the same no. Now consider the train observer. She is also in the middle of the train, but she is moving towards the light, coming from the front strike, and away from the light coming from the back strike. This means that the light from the front lightning bolt will reach her eyes before the light from the back lightning bolt. Because she knows she is in the middle of the train, and because the speed of light is constant for all observers, she must conclude that the lightning struck the front of the train first. For the train observer, the two events were not simultaneous, so who is right? Was the lightning strike simultaneous or not? Einstein's revolutionary answer is that both observers are right. There is no single objective truth of the matter. Simultaneity is relative to your frame of reference. This is not an illusion or a trick of perception. It is a fundamental feature of the geometry of space-time. Two observers in relative motion literally have different definitions of no. They slice space-time into space and time at different angles. An event that is in the present for one observer can be in the past or future for another. Let's put this in a more cosmic context. Imagine two great cosmic events, supernova A and supernova B, happening in two different galaxies millions of light years apart. For an observer on Earth, these two supernovas might explode at the exact same time. I think they are part of our cosmic now. But for an observer on a spaceship traveling at high speed from supernova A towards supernova B will have happened long before supernova A. For another observer traveling from B to A, supernova A will have happened long before B. The set of all events in the universe that you consider to be happening right now is a personal construct determined by your state of motion. There is no universal set of simultaneous events that all observers can agree on. This is the ultimate reason why the concept of a universal now doesn't exist in the universe. If we cannot even agree on which events are happening at the same time, how can we possibly agree on a single present moment? The now is not a universal sheet of paper upon which the story of the cosmos is written. It is a personal perspective, a viewpoint, and just as two people standing in different places will have different views of a landscape, two people moving at different speeds will have different views of the timeline of the universe. The idea of a single objective no is a remnant of a pre-Einstein Newtonian worldview that has been proven to be fundamentally incorrect. Now is a matter of opinion. Number 1, the present has no duration. We have explored the concept of no from many angles: the delays of information, the lack of a cosmic center, the illusions of our brains, and the strange rules of relativity and quantum mechanics. But the most fundamental problem may be the most simple and the most ancient, the one articulated by Augustine of Hippo over 1,600 years ago. The present moment seems to have no duration. Think about it. What is no? Is it this second? But this second is made up of a past part, the beginning of the second, and a future part, the end of the second. So maybe no is this millisecond, but the same logic applies. A millisecond has a beginning and an end. So maybe no is a nanosecond, a picosecond, a femtosecond. You can keep dividing time into smaller and smaller intervals, but you never reach a pure present. Any slice of time, no matter how short, will always have a part that has just passed and a part that is yet to come. The only way to have a now that is free from the taint of the past or the future is for it to have zero duration. It must be an infinitely thin, dimensionless line separating the past from the future. But if the now has zero duration, it effectively does not exist. It is a boundary, not a place. Nothing can happen in an instant of zero duration. Motion is impossible, change is impossible. For anything to happen, for a process to unfold, you need a span of time. A universe that existed only for a single zero-duration instant would be a frozen, static universe. This is the ultimate paradox of the present. We are forced into one of two impossible conclusions. Either the now has some duration, in which case it is not truly present, or it has zero duration, in which case it is nothing at all. Our entire experience is built on this paradox. We feel ourselves to be living in a present moment that has substance and flow. We listen to music, which unfolds over time. We have conversations which require a sequence of words. So we perceive motion. All of these experiences require a no that has some thickness, some duration. This is the specious present that William James talked about, the short window of time that our brain constructs using memory. But the physical universe, as described by our best theories, seems to have no place for such a thick, flowing no. Physics describes the universe in terms of events located at specific points in space-time. It gives us equations that describe the evolution of systems from one state to another. But the equations themselves do not contain a special moving now. The ought in the equations is just a coordinate like or. It doesn't have a built-in flow. So, we are left with a deep chasm between our subjective experience of time and the objective description of the universe given to us by science. Our minds create a rich, flowing no, full of sound and motion, a no with duration. But the universe itself seems to be either a static block of space-time where nothing truly flows, or a series of infinitesimal moments in which nothing can truly happen. The concept of now may be the ultimate user illusion. It is a feature of our consciousness, not a feature of the cosmos. It is a story we tell ourselves to make sense of a reality that is either timeless or composed of non-existent moments. The solid ground of the present on which we feel we stand is, upon closer inspection, either a piece of the past or an infinitely sharp edge of a cliff, a boundary with no substance of its own. It is the most real thing in our lives, and yet it may not exist at all.